Okay. So what we can do is we can go for this one. Just a minute. Okay. So right. Can you open the this one? Can you screen share something? And in the screen itself, we can solve the question. Means, see, there is one option of screen sharing.
Okay.
Okay, you can screen share.
Screen share the.
Yeah.
You mean the Google Drive?
Yes. Yes. Yes.
Okay. Am I sharing the screen?
Yes, you are sharing the screen. Perfect. Can you make it little bigger?
Yeah. Second. Okay.
Yes. Now here what we can do is we can go for tutorial. We can do the solve the problems.
But we haven't gone through the whole chapter, isn't it? Like we go through it or we solve it first?
No, we will solve till whatever we have done. Let us solve it. I need to
Okay.
check how you solve it. Okay.
Okay.
So I like question number 1. This question number 1, you can try. What is given? What is the formula to be used? Can you try it? You just I'll rectify if you are doing mistake.
Oh, okay. I can type here. Okay.
Yeah, you can type here. You can write anything.
Yeah. So 50 kilogram moment balances on one heel of a pair. Heel shoes. If heel is circular and has radius of what pressure does she exert on the floor? Okay. So uh um heel shoes. The heel is circular, has a radius of, so this is like the heel. Uh Radius. So the radius is like this much, right?
Yes.
Okay, so this is like, and then what pressure does it exert? The pressure on the floor. B.
Mhm. So no
Okay.
need to write anything. You can just tell me. So here 50 kg woman balances on one heel of a pair of high-heeled shoes. If the heel is circular and has a radius of this much. So actually, what is happening? So how their sandal looks like? I just forget. Okay, maybe like this. Okay. So so if you look into this, this is the circular one, and the entire weight of the person, entire weight of the lady is just occurring here. So that means 50 times 9.8. This is the total weight. And this weight is distributed across the entire area. So our pressure will be force by area. No need to write rho GH. See, this is where you have to understand. There is no fluid here. So we have to look into the basic formula. Pressure is equal to force by area. So what is force? 50 times 9.8. What is area? Area is pi r square. So pi r square. R is 0.5 centimeter. Remember, conversion is very, very important. So r is equal to 0.5 times 10 to the power minus 2. So its square will be 0.5 whole square times 10 to the power minus 4. Just you have to solve it. Use the calculator and check what you are getting.
So you basically want to convert the radius into meter?
Yes. Yes.
Oh. Why is it times 10 power negative 2?
Because 1 centimeter equals 10 to the power negative 2 meter. So if radius is 0.5 centimeter, it means in meter, it will be 0.5 times 10 to the power minus 2 meter.
Oh, but if centimeter goes to meter, don't we divide?
Yeah, so we are dividing. The 10 to the power minus 2 meter means, okay, let me explain what we are doing here. We are doing this thing. I'm showing here. So R is equal to 0.5 centimeter. You are correct that we have to divide. So 0.5 divided by 100 meter. That itself, it means that 0.5 into 10 to the power minus 2 meter. That's exactly what we got.
Yeah. Okay.
Okay?
Understood.
So now area will be pi r square. So pi into 0.5 times 10 to the power minus 2 square. That will give you pi times 0.5 square times 10 to the power minus 4. So that's why I told you that now we have to calculate this one.
Okay.
Okay?
Yeah. Understood.
Yes, please do it.
Okay.
Immediately use the calculator and finish it. In 1 minute, solve one question. Tell me whether you are getting this value or not. Just check it.
1 second. Let me grab the calculator. I think I forgot it in the back.
Oh, yes, yes.
Okay, I grabbed it.
So how much you are getting?
5 into 0.5 square into 10 to the power of negative 4. 7.85 into 10 power negative 5.
How come you are getting 7 point? Something you are doing mistake. It should not be that one. Okay, so that means I have to come into action. So P is equal to 50 times 9.8. How much you are getting this one? Have you used this formula?
This is the mg.
Yes. So let me do my calculation. 50 times 9.8 divided 3.14 divided 0.5. Boss, I am getting this answer. Exact.
I got
Yeah.
9.
Oh my God, this is horrible. Using calculator, you are doing mistake.
Wait, I'll send you the picture.
Yes, please. Send me the picture. Let me check. Mm. Okay, let me check. Mm. Okay, just a minute. So 50 times where you are doing. Yeah, you are also getting the same answer, right?
Is it the correct answer like this?
Yes, 6.24. What you see, you have to round it off. 623,8873.769. You have to round it off. Write down in scientific notation. Scientific notation means A times 10 to the power B. You have to write like this. So 1, 2, 3, 4, 5, 6. There are 6 zeros, so 10 to the power 6. And this one will be 6.24.
Oh,
Understood?
okay.
Yes, you got the answer.
Okay.
Good, nice. Let's quickly move to question number 2. Question number 2A. You go through the question and tell me what is given, which formula to use quickly.
Okay. Calculate the absolute pressure at an ocean depth 1000 meter. Assume the density of seawater is 1000 kilogram per meter cube and the air above exerts a pressure of. Okay, first we solve A. So we have the absolute pressure at an ocean depth of 1000 meters. So we have H, which is 1000 meter, and we have the density. Okay, and the air exerts pressure of. Okay, so we need to calculate the absolute pressure. So
Yes.
the formula of absolute pressure is uh, where's the thought?
Hmm.
Absolute pressure.
Hey, you ask me now why you are looking at it. Tell me, what is the problem?
Absolute pressure, the formula.
Absolute pressure, the formula is rho GH.
That's the absolute pressure.
Okay, what is the difference between absolute pressure and gauge pressure? Understand this. So every question we will see the theory itself, here itself.
Okay.
So theory is this. If let us take one beaker and there is some liquid here. So now at this point we want to find the pressure. Now if this is H, this density is rho, then we can say that pressure at that point is rho GH. So if you take pressure only due to fluid, that is called gauge pressure. That is called gauge pressure. But if you consider the atmospheric also, which is 1 atmosphere, and then that is called absolute pressure. So absolute pressure at this same point will be rho GH, that is the gauge pressure, plus atmospheric pressure, that is P naught. So when the question said that find the absolute pressure, that means it wants you to calculate rho GH also and then add the 1 atmosphere. What is P naught? P naught is atmospheric pressure 1 atm. 1 atmospheric pressure means 1.013 times 10 to the power 5 Pascal. This you have to add in addition to what you are getting here.
Okay. I got it.
Understood? Yes. Now use this formula to solve that one.
So these notes, are you saving it so you can send me later?
Yeah, we are recording it.
Okay,
We'll
okay.
send you. Shall I erase this one?
Yeah.
Okay.
So basically rho GH. So we have the density in our kilogram per meter cube, so we don't need to convert it.
Mhm. Yes.
Rho
Always try
GH.
to draw the diagram. Show it in diagram what is given. Try to show it in the diagram. Yeah, tell me.
they gave us the atmospheric pressure already.
Yeah, it has given everything. You see, what is the question? Question is, you have ocean, right? So let's say you have ocean. Inside the ocean, which is 1,000 meter depth, means from the surface of ocean, this is 1,000 meter.
Yeah.
So here you have to find the absolute pressure. So at this point, you will have pressure due to ocean water plus pressure due to atmosphere. So pressure due to ocean water will be rho GH. Everything is given. Then
With the
addition.
absolute pressure.
Yes. Then you have to add this one to get the absolute pressure.
Right. But the absolute pressure in kilopascal, don't we need to convert it to Pascal?
Yes, you can do.
Okay. From kilopascal to Pascal, we
10 to the power 3. 1 kilopascal is equal to 10 to the power 3 Pascal.
10 to the power 3 Pascal. If the opposite, it will be multiplied 10 to the power negative 3.
Yes, yes, yes.
So
So
basically 1.3 into the power of 3.
yes.
So the final answer is gonna be
First, find out the gauge pressure. What is the gauge pressure?
the gauge pressure is rho. Rho is 1024 into 9.81 into depth, h, which is 1000. This answer we multiply it with 101 300.
Hey, why you are multiplying, boss? You have to add it. First,
Uh,
first you tell me what is the gauge pressure you are getting. Do it stepwise, don't jump. So first find out the gauge pressure.
yeah. But I got the answer 1.017.
1.017 into 10 to the power
11.
What is the gauge pressure?
Okay, the gauge pressure is
So 1024 into 9.8 into 1000. How much you are getting here?
the answer is 145 440.
Why your
100.
why your answer is not matching with my answer? Wait. So 1000 times 9.8 times 1024. What is your answer?
145 440.
45 440. This one.
Yeah.
What you have taken here? 9.8 you have taken or what?
9.81.
Oh, that's why. Okay, fine. That's why. So now this you have to write down in terms of power. Okay, so what you have to do is this is 3, right? So 3, 6,
1.0 into 10 power
7,
7.
8. 1.1004 times 10 to the power 1, 2, 3, 4, 5, 6, 7. Oh, 440, right? So 3, 6, 7. So this is our gauge pressure. That you have to add. From here, you have to add this one.
So where have you taken to 1.004? Why haven't you until just 1.0?
Until 1.0. No, you can take, I have taken 3 decimal place. You can take 2 decimal place also. Normally, I take 3.
Yeah, but it's gonna be into 10 power 7 in the end, right?
Yeah, it will be. Whatever you will take, it will be. If you take 1.0045 also, it will be 10 to the power 7. If you take 1.00, then also it will be 10 to the power 7. Because 10 to the power 7 will tell you that after sacrificing how many numbers you are writing this. So anyhow, we are writing after 1 point, right? So whatever you write here, it does not matter. It will always come 10 to the power 7.
Okay, understood.
Okay. So yes, then you add, you will get this answer. Perfect. Very good. Now do this question, question number B. Have you understood this 2A?
Yeah,
Good.
understood.
Then 2B.
At this step, what force must the frame around the circular submarine porthole have? At this step, what force must the frame around the circular submarine porthole having a diameter exert to counterbalance the force exerted by the water? Okay, so at this step, there's a submarine. Its porthole has a diameter of 30. How much does it have to exert to counterbalance the force exerted by the density of the water, right?
Yes, yes, yes,
For it not to break.
yes. So, how to do?
Okay, what force must the frame? So, basically, we're calculating the force.
Correct. No need to apply much brain. Force is equal to pressure into area. Simple.
Right.
Okay.
But we have the area and diameter.
Yes. So you have to find out area given diameter. So don't do mistake here. This is the mistake that student do. Here it is diameter. So you have to first find the radius, then do pi r square, and then you
Oh,
multiply pressure to pi r square. Yeah. Try to do it. What you are getting, see.
pi r squared. No, pi r squared is to find the area. But before to find the area, we have to convert the diameter to radius. I know
Mm-hmm.
that diameter is 2 of radius 2r, right? So 30 divided by 2, right?
30 divided by 2. Yes, yes.
Okay. So basically it's gonna be pi 15 square, right?
Yes. Do it pi r square, pi r square.
My answer is for the area is 225 pi.
Hold on, hold on.
Mm.
So, what is the problem you are facing?
So basically I converted the 30 diameter to
Hmm?
radius.
Yes, that's correct.
But
So,
wait,
radius is 15 centimeter.
yeah, do I have to convert it to meter?
Yes, yes, yes. 15 by 100. That is 15
Same.
times 10 to the power minus 2 meter. Just like what we
Understood.
did here.
Yeah. 0.15.
Yeah, 0.15 also you can write.
Okay.
0.15 meter.
Yeah,
Usually
and
I
then we
play
multiply.
yeah, usually I play with this 10 to the power figure. That makes easier calculation. So yes, you can do 0.15 meter. That's correct.
Okay, and then we multiply our answer 0.15 into 6.24 into 10 power 6 because this is the pressure.
Yes.
So the answer into 6.24 into 10 power 6, which is gonna give us 93 6,000 as the force. Oh, it's not the same answer.
Are you getting the same answer?
No, I got
Uh,
I got 93
uh,
6,000.
what is the area you are getting? Let me use my calculator. What is the area you are getting?
Oh, I
Eh,
haven't multiplied by area.
pi. Yes. You have not multiplied with pi, I think.
Yeah, sorry. So pi into 0.15
Whole
square.
square. Yeah.
This answer is multiplied by
Yes,
pressure.
I'm getting this one. Yes, yes, check, check.
Why do I have problems with using the calculator? I still don't
No,
get
no,
this.
it will take time. No problem. Your calculator should be your strength.
Yeah. So, so first 0.15 into pi. 0.15 whole square into pi, right?
Yes, pi 0.115 square.
Into
Tell
pi.
me what you are getting. Yeah, into pi.
I get 0.07.
0.07.
Yeah.
0.07. No, there will be one more. 0.07. And into 10 to the power 7 you have not applied? Was yeah, okay, let me do it. You are doing you are doing calculation mistake. That is the only problem.
Yeah.
There is no conceptual mistake. You are doing numerical mistakes.
Okay.
So our pressure was 1.01 into 10 to the power 7 Pascal. And our area is pi r square. So pi r square, that means 3.14 into 0.15 square, right?
Yeah.
So if we multiply, so force is equal to pressure into area. So 1.01 into 10 to the power 7 into 3.14 into 0.15 squared. Let me use my calculator to check what we are getting. So it is 1.01 times 3.14 times 0.15 times 0.15. Okay. So this I am getting 0.071. Okay, because I'm always using like 3.14, no? That's why I'm getting little bit of difference answer. That's okay. 0.713 into 10 to the power 7. That will give you 7.1 into 10 to the power 5. We are getting, why this? We are getting 7.13 centimeter is there, right? So pi r square. What force must be the frame submarine porthole having diameter? Okay. So 1.01 into 10 per 7 Pascal is there. Pi r square. So 3.14 into 0.15 whole square. So pressure into area will be 1.01 10 per 7 into 3.14 into 0.15 square. So 1.01 into 3.14 times 0.15 times 0.15. It is 0.713 into 10 per 7. That is coming to be 7.13. I am getting this one. What is the answer given? What is this?
I'm getting 7139.
That's okay. That's okay. We have taken 3.14. Actually, this question wanted you to take the full pi value as per the calculator. But
No,
I am using.
I took the pi value, the whole pi value, but I still got 7139.
But our answer is correct because I'm also getting 7.1313. So our answer is correct. Don't worry. I have proved many answers wrong. So our answer is correct. No problem.
Yeah.
Okay. Yeah. Then coming to this is done. This is done. These two questions were based on formula pressure is equal to force by area and pressure is equal to rho gh and also about the gauge,
GH plus
gauge pressure, absolute pressure and atmospheric pressure. These are the 5 concepts based on which this first and second question was there. Now third question is based on hydraulic lift and Pascal's law that we have not seen, so we will see now.
okay. Atmospheric pressure was 1.103, right?
1.013.
1.013, okay. Into to the
So
power of into 10 power of
5.
5. Okay.
Now let us look into the Pascal's law.
Okay. Sir, please don't forget to send me both the recordings, the first tutorial and this one as well.
Okay.
Yeah, so I can go through them after the class.
Yes. So now we will look into Pascal's law. Pascal's law is valid for your confined liquid. confined liquid. Confined liquid means a liquid which is enclosed within a container, full packed container, no air, nothing. So that means if this is the container, full liquid should be there, full liquid. It's not that you take just half of it. Okay. So now in this confined liquid, if you apply pressure at any point, so if we exert any pressure, or if we exert pressure at any point, in this liquid, any point in this liquid, then this pressure, this excess pressure, because we have exerted pressure, that is obviously excess. So then this excess pressure will be transmitted equally in all directions within the liquid. In all directions within the liquid. We will see this. What does it mean? Equally in all directions within the liquid. So you have exerted extra pressure. So let's say by some method, you are just increasing the pressure by 1 atmosphere at any point. Then at each and every point within this liquid, you will see that there will be an increase of 1 atmospheric pressure. So means any change in pressure at any point will be effectively applied at every other point within that liquid. This is called Pascal's law.
Confined means a closed container or open to the air?
No, closed container with full packed liquid, full packed.
Oh,
Confined liquid means full packed liquid, full packed.
but how can the atmospheric pressure exert on the liquid if it's not opened?
No, we are not talking about atmospheric pressure. We are talking about simple pressure. Simple
Oh,
pressure. Nowhere we have mentioned atmospheric pressure. Okay, in Pascal's law question, never take atmospheric pressure until and unless question says that.
yeah.
Okay? In Pascal's law, there is no meaning of gauge pressure, absolute pressure, nothing. It's simply that if we have a confined liquid at any point, if you exert external pressure, that pressure will be transmitted equally in all directions within the liquid.
Understood.
Right?
Yeah.
Now, this Pascal's law is very important because of two applications. So, one is hydraulic lift. We will see that. Okay, shall I erase this one?
Yeah.
Okay. Now, the thing is, I like physics and maths both. Okay. Now, let us see applications of this Pascal's law. Application of Pascal's law. The very important is hydraulic lift. Hydraulic lift, based on which next two questions are there. In hydraulic lift, what happened that you see, you can imagine that you have taken your car to one garage, okay, one service station, and you have kept your car here. Then one person, just like slim boy, he will press a button here. He will press some button here, and suddenly your car will, with the platform, it will grow up. It will just raise up. So what he has done that this car now lift up, right? So actually they use this Pascal's law. So just this boy who has just pressed it, maybe he has applied 10 Newton with his hand. When he has applied 10 Newton, due to his 10 Newton, he is able to raise this 10,000 Newton of a car to a certain height. How it is possible? Because of some arrangement here. There is one arrangement here. It's like this. Inside the garage, this is the inbuilt structure. So here there is liquid. So this is a confined container. They will make a confined container where some specialized liquid will be there. We don't care about the chemical or the liquid. Matter here is there will be two cross section. One will be small cross section. Another one will be big cross section. Okay. Let's say this cross section is cross sectional area is small a and this cross sectional area is capital A. Now, since the entire liquid is confined, we can apply Pascal's law here. So when this service person is applying a small force on this piston, the pressure which is developed here is given by F by small a, small f by small a. This is the pressure which is exerted at this point. This pressure will be equally transmitted to the other side. So the pressure which is getting transmitted to the other side will be capital F by capital A, where F is the force with which this piston is moved up, capital F. Why we have equated pressure on both sides? Because of Pascal's law. So we can write F by A, that is small force by small area of cross section, is equal to bigger force by bigger area of cross section. Now this is called hydraulic lift. Now the question will ask you that we have a bigger cross sectional pipe, a smaller cross sectional pipe, and we are applying a force. What is the force exerted on the other side? So we have to simply use these formulas, only this formula. Got it?
Okay. Yeah.
There will be small cross sectional, there will be bigger cross sectional pipe. For the small cross section, we will write F by A, where small a is the area of the smaller cross section and small f is the small force that you are applying here. Okay. Then capital F by capital.
The force is exerted by a liquid, right?
Yeah, both force is exerted by the liquid, but person will ask you in this manner, and interpretation will be this, that you are applying this small f by your hand, but in return you are getting this capital F, big F. Understood?
Yeah.
So we will use this formula now. So you can write down this formula. Now we will do the question. There is another application, hydraulic brakes, but that is normally not asked. It is quite complicated. Very simple one is hydraulic lift.
Okay.
So shall I read this one?
Yeah.
Now do question number 3. Understand this.
Okay.
Okay. Read the question. Can you scroll it up? Yes, please. Good.
Okay. In a car lift used in a service station, compressed air exerts a force on a small piston that has a circular cross section and a radius. This pressure is transmitted by a liquid to a piston that has a radius of. So this is basically like. This is the small f and small a, and then no wait. The pressure is transmitted by liquid to a piston that has radius of 15. No. Wait, and a car used inside compressor exerts force on the small piston that has a section of. Okay, this is the small section, and this is the bigger piston. Okay, what force must be compressed air exert to lift a car weighing 3,300 Newton? Okay. So basically, we have a car that weighs 13,300 Newton, right?
Yes, yes.
And then we're gonna compress air to exert a force on a small piston.
Correct. So basically, you have to, by this question, we can easily understand that this is based on hydraulic lift.
Yeah.
So, and we know that the formula is small f by small a is equal to capital F by capital A. Now, the car weight will be capital F. Capital A will be, you have to find out pi r square. Small a will be pi r square, this one. You have to find out this small f. Okay?
Okay. Yeah. So we have all the
Yes,
values except small f.
correct. So yeah, can you do it?
What air pressure produces this force? Oh, so basically, we're not finding the air pressure. We're finding no, we're finding the force.
Yeah, you have to find out the force.
I thought we were finding the air pressure.
No, no. After this force, you just this ratio will be your answer. This ratio. Simple.
Okay.
Anyhow, you can easily calculate this capital F by capital A. But let us first find out the small f.
Yeah, but we have to convert first, right?
Yes, you have to convert centimeter into meter both side.
Okay.
Yeah, can you give me just 1 minute? There is a call from medical. No? Just one
Yeah,
minute.
take it. يعني السيشن دي أول واحدة ممكن تعمل ما ينتهيش. يعني شكلها تعمل رجعت الساعة كام؟ 6 صح؟ ما ينتهيش؟ تلميذ دلوقتي؟ ليه هتسلميني الريكورد؟ متهيألي ما بيقفلوش الحاجات دي. تقولي له بس عملته، بس هعمله اديت بسرعة خلاص مش مشكلة، أنا أقدر أصورك عادي، بس أنت يعني قادرة شكلك تعبان. خلاص. حاجة زي كده. ماشي. هي الأمانة مش 20، هي تقريبا ربع ساعة ولا حاجة ولا أقل كمان. المهم خلاص نبدأ.
Okay, so yes, tell me what you are getting.
So basically 5 into 10 power negative 2 is gonna be 0.05.
I am afraid of your calculations.
No, no, no.
Okay, okay, do it, do it. Do it. It will take some time. Yeah, do it.
0.15. So to find the small f, we have to do the math thing, right? We how do we
Yeah,
do it?
you can wait. What you can do now? You can do it in your notebook. No need to write here because it's very difficult for you to write here.
Okay.
So you do the calculation in your notebook and tell me whether you are getting this answer or not. So basically, what we have to do is f by pi r square. So pi r square is 0.05 whole square is equal to capital F 13,300 divided by pi
Yeah.
0.15 square. Pi will cancel out. So we will get F is equal to 0.05 whole square multiplied by 13,300 divided by 0.15 whole square. This you have to do.
Okay. 0.05 square. Okay, so I got 1.48 into 10 power 3. Yeah,
At the same answer, right?
yeah, same answer.
Perfect. Now, air pressure. Air pressure means you can just find out capital F by A, or you can find out a small f by small a. That will give you air pressure. So, yes, you can do it. Like capital F by capital A, you can calculate. That will give you the pressure.
That's for question 4.
No, that's for the second bit.
Oh, we need to find two things.
Yes. So, pressure is equal to capital F by capital A, you can do. What is capital F? 13,300. What is capital A? Pi r square. That is pi times 0.15 whole square. Yes. Can you do it? Just check what you are getting.
Air pressure is basically pressure is equal to force over air. It's not like atmospheric pressure or anything.
No, no, no need to do that one. I told you, na, in Pascal's law, don't do it.
Yeah, okay, okay. Eh,
I think we need to meet daily, otherwise we will be unable to complete that.
1.8 into 10 power 5, correct.
Perfect. Very good. Now do question number 4.
Okay. The small piston of a hydraulic lift has a cross-sectional area of, and its large piston has a cross-sectional area of. What force must be applied to small piston for the lift to raise a load of 15 kilonewton and surface station? This force is usually exerted by compressed air. Okay, so basically I have a small piston of a hydraulic lift. Is it the same? Hydraulic means liquid, right?
Yes, yes, same thing.
There's a cross-sectional area of cross-sectional. What's that?
Cross sectional means that this, if you have this one, this is called cross sectional area. Means area. Just this word is typically they are given to frighten the students. It's simply area.
Okay, so the small piston has a cross-sectional area of 3 centimeters square.
Yes.
So small a is uh, but it's centimeter square, so we have to convert it to meter square.
Always.
But the square is it like different? Do we multiply by 10 negative 2?
Uh, so 200 centimeter square, na? So centimeter square means 1 centimeter square is 10 to the power minus 4 meter square. Hmm?
Uh, no, I'm talking about the 3 centimeter square.
3 centimeter. Yes. The same thing. I am telling you how to convert centimeter square. So if you have centimeter square, then you multiply by 10 to the power minus 4. See,
Yes,
area
meter
is given.
square.
Okay, okay. Tell me.
Basically, like negative 2, you made it negative 4 because it's centimeter square.
Yes, yes.
Ah, okay, okay.
So
So basically,
small area will be 3 into 10 to the power minus 4 meter square. Bigger area will be 200 into 10 to the power minus 4 square.
okay. So
Okay?
basically, centimeter to meter, 10 negative 2, but centimeter square to meter square, 10 power negative 4.
Yes. Yes.
So the small area is equal to the small negative 4. We're gonna get, yeah, okay. So now we found the small a and the big A. Uh, small f over 3 into 10 power negative 4 is equal to big F.
Yes.
The big F is the 15 kilonewton.
Big F
So
is 15 kilonewton. Yes. Then what
first,
to do?
okay, so the 15 kilonewton we converted to Newton,
Yes.
which is gonna be into 10 power 2, right?
10 to power 3.
3,
Kilo means
3.
10 to power 3.
Okay. So basically, 15 into 10 power 3 over 2, uh, yeah, 200 into 10 power negative 4. Okay,
So,
so yeah, so the pi, this is here pi and here pi, here square and here square. So the pi gets cancelled. So it's gonna be small f is equal to 3 into 10 power negative 4 square into 15 into 10 power 3 over 200 into 10 power negative 4 square. So
yeah, tell me.
and negative 3, 200 into 10 4 power 2. So my answer is
What is your answer?
what mistake have I done now? Oh, I didn't put the square. I didn't put the square.
Yes. So, correct it and tell me what you are getting. Yeah, now what you are getting, tell me.
Even worse. I don't know. 1 second. I'll take photo.
Okay, it's done 200. Okay, let me do it. So f by a 3 times 10 to the power minus 4 is equal to, let me do it. So let me do it here. F by small area 3 times 10 to the power minus 4 is equal to capital F. Capital F is 15 kilonewton. Okay. So 15 times 10 to the power 3 divided by 200 times 10 to the power minus 4. Anyhow, this will cancel out. So F is equal to 3 times 15 by 200 into 10 to the power 3. Without calculator, we can do it. So it is 3 into 150 by 2. 3 into 150 by 2, that means it is 75. So 3 5 is 15, 2 2 5. I'm getting exactly this answer without using calculator.
Isn't it the area is pi r square?
No, area is already given. It is not the radius.
Ah,
Area is given. That's why unit is centimeter square. Otherwise, it would have given radius of 3 centimeter, something like this.
okay.
Got it?
Yeah, I was doing everything correct, and instead I just put the square. Okay. So there's no square.
No, no square.
When I remove the square, yeah, exactly the same answer, 225.
Exactly. You did extra thing. You have squared. That's why you are not getting the answer.
Okay. Yeah, now I understood.
So we have seen Pascal's law, hydraulic lift, absolute pressure, atmospheric pressure, gauge pressure, force, pressure definition, and pressure is equal to rho gh. What are the other questions, Somi?
Yeah.
Yeah, I have another class now. Student is waiting. She is from Dubai. Okay, show me the other questions. 5, 6. Okay, for this we have to see Archimedes principle. Just one concept and this will be done. Okay, that we can do tomorrow.
Okay, got it. For now, I'll just memorize the things we did.
Yes, please.
Okay.
Yeah, okay. So are you comfortable or not? Now you can solve the problem related to those topics.
Yeah, I can. But sir, please also send me the recording.
Yes, yes, yes. Boss. I have continuous classes till my 1 o'clock. After that, I will send you.
Okay, sir.
Yeah. Okay then. Bye bye. Thank you.
Thank you, sir. Have a good night.
Good night.